Yeah.
That was my little bit of organizing competition. I didn't do anything else.
So good morning everyone, a very good morning to all the beautiful and bright minds, future academicians, leaders. So smile is a curve that sets everything straight and is the best universal welcome. So with so many cheerful faces around, I am very pleased to be here today as a local convener of the DAE Symposium on Nuclear Physics 2025 to extend all a very hearty and warm welcome with deepest feelings of gratitude on behalf of the Chairman SNP Dr. Aradhana Shrivastava, Convener Dr. Prashant Shukla, Scientific Secretary Dr. Harpool, Dr. Vineet Kumar, HOD Professor H.M. Mittal, Dr. Arvind Kumar, Dr. Sunil, Department of Physics, NIT Jalandhar. It's my immense pleasure to invite our Director, Professor Vinod Kumar Kanodia ji, to please escort our distinguished Chief Guest, Dr. S. Kailash, to the dais. I now request our HOD, Dr. H.M. Mittal, to please escort Dr. Aradhana Shrivastava to the dais. I now invite Dr. Prashant Shukla, Dr. Harpool Kumawat, Dr. Vineet Kumar to please come on the dais. So for me to sit on the dais, I have to invite Navpreet and Gautam to please take over.
Thank you so much, ma'am, for opening the event. It is now our privilege to take the proceedings forward. To begin this auspicious occasion, we move towards a tradition that symbolizes purity, knowledge, and positivity.
Light is a symbol of hope, wisdom, and new beginnings. As we embark on this special event, may the flame of knowledge guide us towards excellence. So we would now like to invite our respected dignitaries for the lamp lighting ceremony.
या शुभ्रवस्त्रावृता या
Thank you, esteemed dignitaries, for gracing this moment with your presence.
To honor our distinguished chief guest, Dr. S. Kailash, Senior INSA Scientist, I now invite Professor Vinod Kumar Kanojia, Director NITJ, to present a floral honor as a gesture of warm welcome. As a mark of deep appreciation, we wish to present a special token that reflects the rich cultural heritage of Punjab.
Thank you, sir. Next, I invite Dr. Prashant Shukla, Convener SNP 2025, to present a warm floral gesture to Professor Vinod Kumar Kanojia, Director NITJ. And a heartfelt token symbolizing our deep appreciation.
Thank you, sir. Moving ahead, I now request Professor H.M. Mittal, Head Department of Physics, NITJ, to come forward and honor Dr. Aradhna Srivastava, Chairperson SNP 2025, with a floral welcome.
Thank you, sir. Next, I request Dr. Harful Kumawat, Scientific Secretary, SNP 2025, to present a bouquet to Professor H.M. Mittal, Head of Physics Department, NITJ.
Thank you, sir. Continuing with our ceremonial acknowledgements, I request my co-anchor, Ms. Navpreet Kaur, to kindly come forward and honor Dr. Prashant Shukla, Convener SNP 2025, with a bouquet. Thank you, ma'am. Next, I request Mr. Dhananjay Singh to come forward and offer a symbol of our sincere welcome to Dr. Haleen Daya, local convener, SMP 2025.
Thank you, Dhananjay. Moving ahead, I request Ms. Bhavna Taylor to come forward to honor Dr. Harful Kumar, Scientific Secretary, with the bouquet and the token of appreciation.
Thank you, Bhavna. Moving forward, I request Ms. Chestha to come and honor Dr. Vineet Kumar, Scientific Secretary, SMP 2025, with a bouquet.
Thank you, Chestha. And with that, we invite Dr. Vineet Kumar to take charge of the formal inaugural ceremony.
Thank you, Navpreet and Gautam, for seamlessly conducting the opening segment. A very warm welcome once again to everyone present. I would now like to invite Dr. Prashant Sukla, Head Theoretical Nuclear Physics and Quantum Computing Section, NPT BARC, and convener of the 69th DAE Symposium on Nuclear Physics, to deliver the introductory remarks.
Good morning, everyone, and a warm welcome to SNP 2025, held in Punjab, the land of 5 rivers, also known as land of sacrifice. It is my privilege, on behalf of the organizing committee, to extend a warm welcome to all the participants and esteemed dignitaries for the inaugural ceremony of the 69th DAE Symposium on Nuclear Physics, SNP 2025. We are truly honored and delighted to have with us today distinguished dignitaries such as Dr. S. Kailas, Senior INSA Scientist and former Director, Physics of BARC, Professor Vinod Kumar Kanojia, Director, NIT Jalandhar, Dr. Aradhana Srivastav, Head Nuclear Physics Division and Symposium Chairman, Professor H.M. Mittal, Head Department of Physics, NIT, Professor Haleen Daya, Department of Physics, NIT and Local Convener, Dr. Harful Kumawat and Dr. Vineet Kumar, Scientific Secretaries, SNP 2025. On behalf of the organizing committee and all the participants of SNP 2025, I extend my heartfelt gratitude to you, sirs, for taking time out of your hectic schedule to grace the occasion with your presence. The DAE Symposium on Nuclear Physics, held annually, is one of the oldest and most prestigious events in the field of nuclear physics in India. This year, the symposium is hosted by NIT Jalandhar. It is established in 1987 as a regional engineering college and is now declared as Institute of National Importance in 2007. In recent years, we have seen a significant increase in participation, with approximately 500 registered participants this year, in addition to local students. Over 684 contributory papers have been accepted across various subdisciplines. The largest contributions come from nuclear reactions and nuclear structure, together amounting 350 papers, which consists of about half the total submission. Other prominent areas include nuclear astrophysics, hadron physics, and astroparticle physics, relativistic nuclear collisions and quark-gluon plasma, electromagnetic interactions, and rare event searches. This year we have added a new category, quantum computing and artificial intelligence in nuclear physics, which has already got more than 30 papers in the first year. Additionally, there are 100 papers focusing on nuclear instrumentation, techniques, and applications. The symposium features 21 invited talks by distinguished experts, including 7 speakers from international laboratories. The plenary sessions are held daily in this central seminar hall before lunch, while the poster and parallel session take place in the IT park just across the ground where we have arranged the tea, etc. There will be 88 oral presentations, each lasting 10 minutes, conducted in 3 parallel sessions that are in IT park. In addition, there are 596 poster presentations which form a major component of the conference. So each day there will be 200 posters displayed for 2 hours for first, second, and third day. We have 7 poster committees which will be tasked with selecting 10 best poster presentations to be awarded at SNP 2024. Over the course of the symposium, 31 thesis presentations will be featured on posters and they will be displayed on all 3 days. 3 of the best theses selected by the evaluation committee will be given the opportunity to present in a special thesis session on the 4th day of the final selection of CVK Baba Best Thesis Presentation Award given by Indian Physics Association. Additionally, the Young Achievers Award by AA will be presented to encourage and motivate emerging researchers in the field. This year, the Young Achiever Award is already taken by Physics Department, NIT. It will be announced in the last day. Yesterday, we held a pre-symposium orientation program on search of rare events in nuclear physics that we do every year, 1 day before the symposium. So it was attended by about 120 participants. The program was divided into 2 parts. So morning part is 4 classroom lectures on theory and experimental techniques, and there were 3 experimental hands-on sessions in the afternoon, both of which were well appreciated by the students. The symposium has an extremely busy schedule over the next 5 days. In addition to the technical session, we have arranged an interesting evening talk today. The organization of SNP 2025 with over 600 participants required the tireless efforts of many individuals and agencies. I would like to especially acknowledge Scientific Secretary Dr. Harful Kumawat and Dr. Vineet Kumar, Professor Harleen Dahiya and Professor Mittal and their team who contributed at every stage of planning and execution. Finally, I thank Symposium Chairman Dr. Aradhna Srivastav for her continuous guidance and support. I would especially like to mention that NIT Director Professor Kanojia personally monitored many of the arrangements. Salute to you, sir. There still may be some glitches as we are not really the event manager. We are managing scientific conference. The aim is to have a good scientific conference, and I urge the young people who are the future of the nuclear physics, please take full advantage of the conference. Before I conclude, I would like to once again extend a heartful welcome to all the dignitaries, scientists, faculties, students and participants to the 69th DAE Symposium on Nuclear Physics. We hope that you have a fruitful, memorable experience and enjoy the pleasant weather. Thank you.
Thank you very much, sir, for outlining the vision and essence of this symposium. We now request Dr. Harleen Dahiya, local convener of 69th DAE Symposium on Nuclear Physics, to share her message with the delegates.
So I'm once again extremely privileged and delighted to welcome welcome all on and off the dais to introduce and welcome our chief guest, Dr. S. Kailash, who is a senior scientist at the DAE Center for Excellence in Basic Sciences, a position he has held after serving as the director of the physics group at Bhabha Atomic Research Center. Dr. Kailash, Fellow of the Indian Academy of Sciences and Fellow of Indian National Science Academy, is an accomplished researcher in the field of nuclear physics and will be delivering the keynote address shortly. It's an honor to be graced by your presence, sir. I am so thankful to you for accepting our invitation and agreeing to be present here despite your busy schedule. Your presence fills us with pride and inspiration. So let us give a big round of applause for our guest of honor, chief guest. I am sure the young researchers will gain a lot. In fact, I am without a doubt especially grateful to the invited speakers who have all come to NIT Jalandhar in such a cold weather. Strong leadership is the foundation of our institute, and I consider it a very special honor to thank Professor Vinod Kumar Kanojia ji for setting high expectations for us. To be very honest, he fostered a sense of support and working environment, and his encouragement led us to a very positive and inclusive working environment. We appreciate how concerned you were about each and every aspect and admire the way each problem was solved. I must admit that you modeled how to follow a strong set of values in your daily work. In fact, we can never thank you for helping us by supporting us. Thank you, sir. I would now extend a heartfelt welcome to Dr. Aradhana Shrivastava, who is the chairperson and head of the Nuclear Physics Division, BARC. It's a privilege to have such a distinguished guest here. Your presence adds immense value to our event, ma'am. Welcome, ma'am. I consider it a great honor to welcome our registrar, Professor Ajay Bansal, you can say, for supporting us in all means. Dean Research, Professor Rohit Mehra, and Professor Agnihotri. I also welcome the Dean Planning Development, Professor Subhash Chandra, Dean Students Welfare, Professor Anish Sachdeva, who have been instrumental in giving every support towards organizing this symposium, and we will always be indebted to you for your invaluable support, sir. I appreciate the efforts of the entire National Advisory Committee and the local organizing committee for giving very constructive suggestions and help. Now, the volunteers. Volunteers do not necessarily have the time, they just have the heart. The faculty and PhD students of our department have been working day and night, and you will see that they will be helping and guiding you throughout the symposium. I am extremely thankful to Dr. Arvind, Dr. Sunil, Kiran, Shishram, Vinod, Shubchintak, and the students Nappreet, Manpreet, Gautam, Cheshtha, Abhi, Dhananjay. I will not be able to list their names right now. I also feel privileged to see so many colleagues. We are without a doubt especially grateful to you. In this symposium, we have very senior researchers, young postdocs, and even younger students. So this in-person interaction among us is the most important advantage I see about the symposium. So let's come together to share ideas and learn from each other. Please make the most of every session and networking opportunity. I and everybody present here will agree that these interactions are not just professionals, but also personal, and they end for lifetime. So I welcome you all and wish you the very best by reminding you again that coming together is a beginning, keeping together is progress, working together is success. Thank you.
Thank you, ma'am, for your encouraging words. Your efforts have been vital in shaping this event. It is now my pleasure to invite Professor H.M. Mittal, Head Department of Physics, NIT Jalandhar, to address the gathering.
Good morning to all of you. Honorary Chief Guest, Dr. S. Kailash, INSA Senior Scientist, CEBS, Professor B.K. Kanojia, Director NIT Jalandhar, Dr. Aradhana Shrivastava, Chairman SNP 2025 and Head Nuclear Physics Division, Bhabha Atomic Research Center, Dr. Prashant Shukla, Convener, Dr. Harleen Daya, Local Convener, Dr. Harpul Karmawat, and Dr. Vineet Kumar, Secretary SNP 2025. esteemed dignitary, distinguished guests, respected colleagues, and dear participants from India and abroad, a very warm welcome to all of you. It's my pleasure, honor, and privilege to welcome all of you to the 69th DAE Symposium on Nuclear Physics at NIT Jalandhar. The DAE Symposium is being held for the first time in NIT Jalandhar. The Department of Physics established in 1989. We have grown up since 2006 when department has started PG and PhD program. Till date, 380 students complete their MSc degree and 45 students complete their PhD degree. And 36 research scholars are working at present in the Department of Physics. Faculty members of the Department of Physics have completed various projects funded by different funding agencies such as DST, CSIR, DAE, ISRO, ANRF and IUC. At present, many research projects are ongoing in the Department of Physics, including FISH project. Over the coming days, we will hear from expert, eminent scholars and researchers, each bringing unique perspective, experiences and insight. Their insight will not only enrich our understanding, but also inspire new pathways for research and innovation. I wish to acknowledge the tireless effort of the organizing committee, faculty, staff and student volunteers whose meticulous planning has made this symposium possible. Wishing you all a productive and enriching time ahead. I also wish for your present stay in Jalandhar. Thank you very much.
Thank you very much, sir, for your insightful remark. Next, we have with us Dr. Aradhana Srivastav, chairperson of S&P 2025 and head of Nuclear Physics Division BARC. A distinguished scientist and a visionary leader, Dr. Srivastav has contributed immensely to the growth of nuclear research in India. Her leadership and scientific vision continue to guide several programs of national importance in nuclear physics. Madam, I invite you to share the symposium over.
Thank you, Vineet, and very good morning, distinguished dignitaries on the dais, Dr. Kanojia, Director of NIT Jalandhar, Dr. Mittal, Head of the Department, Dr. Prashant Shukla, Symposium Convener, Dr. Halim Dahiya, Local Convener, Dr. Kumawat, Scientific Secretary, Dr. Vineet Kumar, Scientific Secretary, esteemed invitees, colleagues, participants and friends. It is with great honor and pleasure that I welcome you all to the 69th Symposium of Nuclear Physics. This prestigious symposium has its roots in visionary initiative of Dr. Homi Bhabha, who in 1957 laid the foundation for the annual DAE Nuclear Physics Symposium. The primary goal was to establish a dynamic scientific platform for the nuclear physics community to present their research, exchange ideas, and foster collaborations. During the fourth symposium held in Voltaire, Dr. Bhabha envisioned organizing this event outside Bombay to inspire research across all Indian universities with the hope of stimulating students and teachers by showcasing the remarkable work being done across the country. This symposium is mother of all DAE symposia. Over the past 68 years, it has been held across various regions of India, including the East, West, North and South. We are privileged to host it here in Punjab for the 5th time. The previous 3 being in Chandigarh in early days like 1964, 1972, 1999, and most recently in Patiala at Thapar University 2017. I extend my heartfelt appreciation to NIT Jalandhar and especially to Dr. Kanojia, who has personally overseen every aspect of this event. Thank you very much, sir. This year's symposium covers a broad spectrum of topics, from low energy nuclear physics, nuclear structure and reactions, to high energy physics such as coagulant plasma, as well as nuclear astrophysics, instrumentation, techniques, and applications. We are honored to host 21 invited talks by distinguished researchers, which promise to be both insightful and inspiring. A significant highlight of this symposium is the participation of our young researchers, comprising approximately 66% of the registered attendees, who represent the future of the Indian science. Additionally, the increasing involvement of women, making up nearly 34% of participants, reflects a positive trend towards a greater diversity and enthusiasm within the field of nuclear sciences. Yesterday, we conducted an orientation course for the students on rare event researches, which was well conceived and executed. During the symposium, there will also be special talks on Mega Science Vision document, which actually lays the roadmap for future of nuclear physics in India, and we anticipate this will spark vibrant discussions and generate new ideas. There will be awards from one sponsored by IPA CVK Baba Award for the best thesis presentation. Additionally, awards will be given to 10 best poster presentations as briefed by our convener. And from this year, from year 2022, we introduced Young Achiever Awards to encourage and recognize young researchers in the field. We are privileged to have with us eminent stalwarts of the field, our esteemed chief guest, Dr. Kailash. And we are also going to hear from a distinguished evening speaker, Dr. Kuldeep Chand Agnihotri, today evening. And finally, we sincerely thank all the speakers and participants for overwhelming response and participation in the symposium. With that, I look forward to exciting presentations of new research, intense deliberations, fruitful collaborations, and the emergence of new directions from the symposium. And I thank you very much.
Thank you very much, madam, for the comprehensive overview. I now request Professor B.K. Kanodia, Director, NIT Jalandhar, an inspiring leader and a pillar of support for this conference, to deliver the welcome address.
Thank you, Dr. Vineet, and our chief guest, Dr. S. Kailash ji, and distinguished chairperson of this symposium, Dr. Aradhana Srivastav, respected scientific secretary, Dr. Harful Kumawat ji and Dr. Vineet Kumar ji, and convener, Dr. Prashant Shukla, and local convener, Dr. Harleen Daiya, head of Department of Physics, Dr. H.M. Mittal, and eminent scientist, faculty, member and delegate from India and abroad, my dear students, ladies and gentlemen. It is my great honor and privilege to welcome you all to a Dr. B.R. Ambedkar National Institute of Technology, Jalandhar. On this occasion of the 69th DAE BRNS Symposium on Nuclear Physics. Hosting this highly respected and long-established scientific event on our campus is a moment of pride for the entire NITJ community. Just I want to share that I request Harleen Daiya. Harleen Daiya is very hesitant to organize this event. But I insist that whatever support is required, I will provide you. You will organize this BARC event. So I think that she has taken an initiative. So you should give a big hand to Dr. Harleen Daiya. So on this moment, I have seen that this type of Dr. Aradhana Srivastav, she has discussed that how the initiate of this event from a beginning. So I have seen that one of a scientist, Professor Sudhakar Rao, he is working in a NASA. So currently he is established of one of a society is bombs, especially for a microwaves area. But I have seen that how he is encouraging of a young scientist or young researcher that he is providing all the TADA and host, whatever is hosting facility is there, everything he is providing from their bombs. So I think that one of a scientist he is encouraging our young students. So that's, I think that this conference is also the encourage of our young scientists. So I have been informed this This year's symposium brings together more than 500 participants, including a leading researcher and mentors and young minds from across the India, as well as from a country such as Japan, USA, and UK, Australia, and Korea. Young presence not only add to the academic stature of this symposium, but also reflect the global relevance and collaborative spirit of a nuclear physics community. This symposium is especially significant in today's global landscape, where nuclear science and technology play a crucial role, not only in energy security, but also in healthcare, national defense, and environmental sustainability, and space exploration, and cutting-edge material research. And I hope that as scientific insights and collaboration emerging from this platform will directly contribute to a shaping solution for a rapidly changing world. At NIT Jalandhar, we take great pride in hosting events that advance scientific and technological excellence. NIT Jalandhar has always believed in excellence, innovation, and service to nation through education and research. In a recent year, the institute has taken a major stride in academic growth, research output, and global visibility. So I take an opportunity to introduce the NIT Jalandhar is a rank 55 in the NIRF 2025 engineering category, and also hold a respective position in the Time Higher Education and QS Global Ranking. The institute offers a 14 BTech program and 20 MTech specialization amongst with the 3 MSc program in physics, chemistry, and mathematics, and MBA program, and PhD in all discipline, and BSc B.Ed program, and catering a wide spectrum of scientific and technical education. Our faculty members are highly qualified and committed. Last year alone, they published more than 1100 research papers in a respective international journal, and 24 of our faculty members were recognized amongst the top 2% scientists globally, as per the Stanford University study. The institute has secured an external funding project more than worth 53 crore and generated 5 crore through the consultancy project in just last year. NIT Jalandhar has maintained an excellence track record in placement with a placement percentage of 92%. The highest package of last year was 52 lakhs. And this year, student has already received a outstanding offer of rupees 1.2 crore. The institute has recently been sanctioned the 3 FIST project worth of 5.5 crore and has 2 Center of Excellence in 5G and beyond and cybersecurity. To promote innovation and entrepreneurship, NIT Jalandhar has established a technology business incubator and an ISRO-funded Space Technology Incubation Center. In addition, the institute is expanding its national and international collaboration and has recently signed in an MOU with the IIM Visakhapatnam for a dual degree program of enabling students to pursue an MBA alongside their degree at NIT Jalandhar. All these accomplishments represent the collective hard work and dedication of our faculty, researchers, students, and staff, and reflect our commitment to achieve new heights in teaching, research, and innovation. Again, this backdrop, hosting the DAE BRNS Symposium on nuclear physics holding a great significance for us. On behalf of NIT Jalandhar community, I extend my sincere thanks to Department of Atomic Energy and Board of Research in Nuclear Science for giving us the privilege to host this prestigious symposium. It is always a pleasure for NIT Jalandhar to organize events that promote learning, collaboration, and knowledge sharing. I would also to express my appreciation to the organizing team for their hard work and dedication in planning and executing this event. We have tried our level best to make all arrangements for your stay and for a smooth conducting of programs. I hope we are able to meet your expectation. It is our pleasure to ensure that your experience here is a comfortable, meaningful, and memorable. I encourage all participants to explore the campus and interact openly and make the most of these enriching days for discussion. With these words, I once again extended a warm welcome to all of you. We are truly honored to have you with us. I wish the 69th DAE BRNS Symposium on a Nuclear Physics great success. Thank you. Jai Hind, Jai Bharat.
Thank you, sir, for your motivating words and continuous support. It is now my honor to invite our chief guest, Dr. S. Kailas, Senior Scientist of INSA at CEBS Mumbai, former Director of Physics Group at PARC, and former DAE Raja Ramanna Fellow. An esteemed nuclear physicist and an accomplished tennis player, Dr. Kailas has inspired generations of researchers. Sir, we request you to kindly deliver the inauguration.
Dr. Kanodia, Director, NIT, Dr. Mittal, Dr. Aradhana, Dr. Dahiya, Dr. Shukla, Dr. Harpur, Dr. Vinit Kumar, my old friends, Professor Jain, Professor Pillai, Professor B.P. Singh, and many others whom I am not able to see from here, distinguished faculty members, research scholars, and invitees to this 69th Symposium on Nuclear Physics. I consider it as a divine grace that I'm able to be here in front of you today. You know that the last few days, due to cancellation of various flights, particularly by Indigo, so I was to miss this symposium. I think thanks to the Herculean efforts made by Dr. Shukla and Dr. Harpur, they somehow made it possible for me to come here and stand in front of you today. I thank both of them for their great efforts. I also thank them, the organizers, for inviting me to be the chief guest today. I think sometime back, I think the organizers were planning to get Dr. Mohanty, a distinguished nuclear physicist and who happens to be the chairman of Atomic Energy Commission, to be the person today, to be the chief guest. But then knowing, the position of the chairman, that he will be always required to go to Delhi as required. So Dr. Mohanty jokingly told Dr. Kailas is anyway the invited, a keynote speaker, so if I'm not able to come, he can be the chief guest. So he said he is 2 in 1. So I didn't realize that will happen. Finally, Dr. Mohanty is not able to make it, so I'm standing in front of you. It is a matter of great pride that this annual Nuclear Physics Symposium is nearly 70 years old. As Dr. Aradhana mentioned, this is the mother of all symposia funded by the BRNS, Board of Research in Nuclear Sciences, the extramural funding agency of the Department of Atomic Energy. And there are many other symposia, as you all know: Solid State Symposium, Physics Symposium, Accelerator Physics Symposium, Laser, Atomic Physics. There are many other areas which the BRNS has been providing funds so that we can host this symposium. Again, as mentioned by Dr. Aradhana, the symposium's idea series started way back in '57, thanks to the initiative and vision of our founder of Atomic Energy Program in India, Dr. Homi Bhabha, and also Dr. Raja Ramanna. This symposium series got started, and then it was nurtured for the last many decades by Dr. Raja Ramanna. In fact, this year happens to be his birth centenary year. All over India, several programs have been organized in honor of Dr. Raja Ramanna, who has been actually when I was growing up, and in fact the first symposium I attended in 1972 was at Chandigarh. Again, extreme cold weather, and the first time to the symposium. Now I'm of course in a better position, given good accommodation and all that, so there is no problem. Those days it was quite difficult for youngsters to get used to the accommodation and possibly the hot water and things like that. I'm sure the research scholars are better placed now compared to what it was more than 50 years ago. And this symposium series, I think it is one of the main factors which has contributed to the growth of nuclear physics in the country. Of course, I forgot to mention about, there are a number of people. We have been always having the practice of inviting experts in nuclear physics from outside India, and we have been able to get a number of them. I hope all of them. I think David Hind could not come, but I think others must have come, and I again extend a warm welcome to them to come to this part of the country. And one of the outcomes of this symposium, as you know, the symposium started as Low Energy Nuclear Physics Symposium in 1957, but then later on, when the symposium grew up, the numbers became large, and then they decided to split into Nuclear Physics and Solid State Physics Symposium. It happened in 1981 or so. After that, these two symposia are held in different parts and different times. And then, as I always used to wonder, when our nuclear physics strength used to be around 200 or 250, the solid state physics symposium used to be double that number. And their number is growing up, and I'm happy to see that from whatever I heard, the number has grown up almost as solid state physics symposium. I think this time has come where the organizers have to think about, because I think it is very difficult to host such a large number. By maybe the IITs and the NITs can do it. Otherwise, the smaller universities, they will find it very difficult to host such large numbers. Even the auditorium may be difficult to have. I understand from director that this capacity is almost 800. I remember attending a solid state symposium where a SRM university in Chennai, a huge auditorium. In fact, it was so good. First time I'm seeing such a big auditorium in a private university. For the symposium, one of the things which has happened, of course, more than 50 years ago, was the idea of Indian Physics Association, which came out of deliberations in the symposia, this annual symposia, 1970-71. The Indian Physics Association came into existence, which is now nearly 4,000 members. I think it may be right. I think Dr. Aradhana will know exactly the number. And then another thing which happened again due to symposium and experts meeting in the symposium was the starting of the Indian journal, Pramana, Journal of Physics. That idea also came during the symposia, and that journal has come into existence, and it is doing very well with good impact factor, and that's what I understand. For people doing nuclear physics, particularly experimental nuclear physics, the young research scholars, I'm sure they are aware we have excellent facilities in the country in terms of accelerators at the main accelerator centers, as you know, at Delhi, Calcutta, and Mumbai. We also have all state-of-the-art experimental facilities, so you can do very good nuclear physics work, low-energy nuclear physics particularly, in the country itself. Of course, for postdoc, you can go abroad and get exposure to other labs and facilities. But low-energy nuclear physics, I think, thanks to people before us who planned many of these facilities, and it's really a nice situation today. We have, one thing I find, there is so much of competition with limited beam time available, particularly in a place like IUAC Delhi. You have to wait in the queue for a long time to get your beam time. That is a good situation. So that only means we should have more accelerator centers in the country so that the teaching institutions in particular will get benefited and more beam time they will get. people doing experimental nuclear physics in particular, the training in nuclear science and technology, will give you opportunities. Of course, you can always join as faculty members in teaching institutions, but if you don't get, you have other opportunities. As it was mentioned, you can join a semiconductor industry with your background, or you can join a healthcare where you require your expertise in handling radioactive materials. Accelerators will come into help, or you can join electronics and instrumentation, software industry. So you have plenty of opportunities. So this, I always feel experimental nuclear physics, the training makes you an all-rounder because you get exposure to high voltage, vacuum physics, material science, electronics, instrumentation, of course besides nuclear physics or nuclear science. So that is something which people should appreciate, the research scholars in particular, that you have many opportunities. You can go to the nuclear power program. We are going to build many reactors over the years. As you know that we want to, by 2047 or so, we should have 100 gigawatt of nuclear power. So it is 10 times more than what we have today. So plenty of opportunities for nuclear physicists to join this nuclear power program. So I also understand the director is an expert on microwave engineering, so I was telling he can also, NIT can join hands in our accelerator program, because we require a large number of people, not only the DAE, but also the academic institutions and also industry to take part in building this indigenously, many of these accelerators and subsystems. So there are plenty of opportunities for research scholars to take part in. I'm sure, as Dr. Aradhana mentioned, that the Vision 2035 document has been released in nuclear physics, and we should know what are the things which are being planned in the next 10-15 years, and so how we go about achieving these targets, and also what kind of course correction may be required. There are many ambitious targets, and of course with the proper planning, we should be able to achieve many of these targets, and the young research scholars will have a great role to play, because they are the people who will be utilizing many of these facilities when they are built 10 years down the line. So I'm sure this lot of discussions will be there on this. I'm happy that the organizers have provided a time slot for discussing 2035, which is very good to do. As it, right from beginning, even though we had symposia in Mumbai for convenience, for hosting and all that those days, and it was always a policy to once in every third year we come back to Bombay, but 2 years we go out on the invitation of academic institutes, and we have been privileged to go to all over the country. And I'm happy to note last 4 or 5 years we have been still outside Bombay. We have not come back to Bombay. That is a healthy sign. Earlier we didn't have many institutes inviting us because nuclear physics was not part of the university or discipline. So we were not having many people inviting us compared to what it is today. I'm very happy to know that we are not able to go back to Bombay because there are so many invitations from all over the country, which is again a good sign. Another thing again I noticed, 700 research papers, 500 participants, and out of that 70% students. I think it augurs well for future of nuclear physics. So many students participating, which is very nice and healthy for nuclear physics. I only hope the same way the number of faculty in academic institutions also grow up proportionately, so that we'll be able to produce more students and more research scholars who can contribute to the national programs in general. The organizers, I understand, have put in great efforts despite last-minute constraints like the Indigo flight strike and all that. And I'm very happy to note that they have introduced a new session on quantum computing, machine learning, and artificial intelligence in nuclear physics. I think this is a growing field, and it will be interesting to know what are the things which are happening in this field and how nuclear physics can also be part of this important development. Other thing, of course, is very happy to know from our director that he gave all the boost to the secretaries and convener here to host this symposium. I always feel organizing the symposium of this magnitude is like celebrating the marriage of our children. You know, all of you who have experienced this will appreciate what kind of preparation goes in hosting a marriage in the family. So it is as good or even more difficult to organize a symposium of this kind of magnitude, to receive people, students, faculty, take care of their accommodation, food arrangements, sessions to be held at various places, parallel sessions. It is really a great task. I'm sure last 6-7 months, I think my colleagues have been working on it full time and sacrificing their research. Of course, many people all over the country have contributed to this organization of this symposium, and I appreciate all of them for taking time to help in organizing this symposium in this city of Jalandhar. I am aware Jalandhar is very famous for cricket bats, and I think hockey sticks. Of course, this is something, my limited knowledge. I wish I was young so that I could have bought a cricket bat from here and taken home. And anyway, this symposium is, as I mentioned, that it is the 69th symposium, and I wish this symposium all success, and I wish they realize all their objectives, whatever they have planned. In this cold weather, I'm sure there will be hot discussions amongst the participants, and that will make it very lively. I still remember in the field of nuclear fission, we used to, when I was growing up, a lot of discussions. Professor P.C. Sood from BHU, Professor G.K. Mehta from IIT Kanpur, and Dr. Kapoor from BARC, they will all have very lively discussions. It was very educative when these people discuss the topic of nuclear fission. So I am only hoping that this kind of more people from academic institutions should come up, so that we will have a lot of discussions on the emerging areas of nuclear physics, and also the students will be benefited when these kind of discussions take place. And I am sure similar things will happen during this symposium also. We have experts from both India and abroad, and I request the students to make best use of this and boldly discuss with them. Don't worry about raising questions, because many times students do not raise questions because they are all shy. I think you have to come out of that shell. Please use this opportunity. You have come all the way to Jalandhar. Please use this opportunity to discuss with the experts and you can get benefited. So I wish the symposium all success, and thank you once again for giving me this opportunity to be with you. Jai Hind.
Thank you very much, sir, for your inspirational address. Now I invite Dr. Harful Kumar, Scientific Secretary of SNP 2025, one of the key drivers behind this conference, to present the vote of thanks.
Good morning all. I feel truly honored and privileged to have the opportunity to propose the vote of thanks on this special occasion, the 69th DAE Symposium on Nuclear Physics. Thank you is a phrase that comes from heart and is meant to be felt deeply, and today it carries with it our collective gratitude and respect. I would like to extend my heartfelt thanks to all the distinguished delegates on the dais who have graced us with their presence. On behalf of the organizing committee, I express my sincere gratitude to Dr. A.K. Mohanty, Chairman AC and Secretary DAE, Mr. Basin, Director BRC, Dr. Shakuntala, Director Physics Group ERC, for their invaluable guidance and support in organizing this symposium. We are equally grateful to all the members of the National Advisory Committee, National Organizing Committee, and our esteemed invited speakers. Words are truly insufficient to convey our appreciation for their unwavering support, insightful guidance, and dedicated efforts in shaping this event. I extend my sincere thanks to Dr. Prashant Shukla, convener, and Dr. Vineet Kumar, scientific secretary of the symposium, for being with me at every step and for thoughtfully discussing every aspect of the symposium organization. My heartfelt gratitude also goes to Dr. Aradhana Srivastava, chairperson of the symposium, for her continuous guidance and unwavering support throughout this journey. I also thank Dr. Satyaranjan Santra, Head NAS BRC, for his unconditional support for me for this symposium. A special word of appreciation to Professor Vandana Lal and entire orientation team for successfully organizing the course yesterday. I am deeply grateful to all our BRC colleagues and students who assisted in every aspect in a valuable way. I would also like to acknowledge the session chairpersons, member of the thesis committee, members of the 15 poster committees who will be evaluating all the 600 posters, more than 150 members of the screening committee to evaluate the contributory papers. We are equally thankful to the cultural team of NIT Jalandhar for agreeing to present a performance showcasing the richness of Punjabi culture on coming Wednesday. Our sincere gratitude and heartfelt thanks goes to Professor Kanodia. Every time he was with us whenever we visited here, Professor H.M. Mittal, Head Department of Physics, for gracefully hosting this symposium and for extending their support in every possible way to make this event a success. I would also like to acknowledge the immense effort that has gone into organizing DAE SNP 2025, an event that has brought together nearly 550 participants in this regard. My special thanks to Professor Harleen, the local convener who, along with the dedicated members of the local organizing committee, has worked tirelessly to ensure the smooth and seamless execution of all the arrangements for the symposium. I would like to express my sincere gratitude to Professor Anish Sachdeva, Dean Students Welfare and Team, as well as Professor Subhash Chandar, Dean Planning and Development, and his team for their support to arrange the student accommodation in the new hostel. Special thanks to CPWD and NIT engineers except Pradeep and their team for ensuring all the facilities in the new hostel which were fully functional. I am also thankful to all the wardens, security teams, estate office, registrar office, computer center for providing all the necessary support. We would also like to thank Professor Dushen Singh, Head Central Workshop NIT, and his team, as well as the principal of the Deoba College Jalandhar, for providing the poster stands. My sincere thanks to the head of various departments of the NIT Jalandhar for allowing the use of their facilities during the symposium. I also appreciate the support of the head of CSE and the computer center for providing venue and infrastructure for the poster and parallel sessions. There is a large team of professors and students volunteer for the physics department who have been coordinating with us over the past many days for various arrangements. I would like to extend my sincere thanks to all the faculty members of the Department of Physics for their constant effort, guidance and support to the student volunteer team. I gratefully acknowledge the dedication of the student leaders, Cheshta, Manpreet, Navpreet, Avi, Priyanshi, Ritanshu, Harsh, Vidit, Gautam, Dhananjay, Abhishek, Ananya, Bhavna, Neha, Saurabh, Hansa, Vedehi, Aniska, Avinka, Monica, Satyajit, and the list is not complete. The entire volunteer team who have worked tirelessly on the ground to ensure smooth execution of the event. I would also like to thank S. Kiran, Paramjit from the Department of Physics for their valuable contributions. Given the scale of this event, I may have inadvertently missed mentioning some names due to limited time, I sincerely thank everyone who has directly or indirectly contributed to the successful organization of this symposium. I wish all the wonderful stay. I wish a wonderful stay at NIT Jalandhar. May you enjoy the symposium academic session, engage in meaningful interaction and build fruitful collaboration that strengthen and advance your pursuit in nuclear physics research. Thank you. Jai Hind and Jai Bharat.
Thank you, Dr. Harful. It's my privilege now to invite Dr. S. Kailas for the keynote address. And I also request the dignitaries to take their seats in the audience.
Can I have some? Hello? Yeah. This also will be there, or that is not good? Okay, I can just, yeah, thank you. So I'm, yeah. We have a template for nuclear physics and its growth. At least for last 3 decades or so, we always use the slide to say that how nuclear physics is growing and in which way it is growing. One, as you all know, is the ever-increasing energy and density, high energy, high densities, and studying the matter at these extreme temperature and densities or energies. The other one, of course, the evolution or the shape evolution of the nucleus as a function of, again, temperature, angular momentum, isospin, deformation, and these are all the other studies which go. The third one is the study of nuclei away from the line of stability, the drip lines, the proton and neutron drip lines, and super heavy elements or nuclei. So this is the sort of template we have for growth of nuclear physics, and I think it continues to be the same. And in this slide, what is shown here, the three areas, the high energies and densities, and the shape evolution, and origin of elements, and their abundance, and the nuclei away from line of stability, broadly calling nuclear interaction and nuclear stability. And what you will appreciate here is nuclear physics has a rich connection to particle physics or high energy physics on one hand. On the other hand, that is at the high energy region. At the low energy region, nuclear physics has good connection to astrophysics. Again, so this is what I have tried to show in this particular slide, the growth of nuclear physics in different areas and the connection to, of course, this division amongst different disciplines is for our convenience. As you know that physics is one. So you talk about nuclear, the structure and dynamics. These are the two things we talk in nuclear physics, and the same thing solid state physics people also speak, and I'm sure high energy physics people also talk of cosmology or astrophysics also, they talk of structure and dynamics. So this is common theme, whatever disciplines you pursue. First, let me start from what is happening. Again, this talk I have tried to compile based on whatever little I gathered in the last 1 or 2 years, going through some of the journals. I have the practice of going through some journals and try to download some things which of interest to me. So what I am doing today is sharing with you what all I found interesting, some of them, because everything cannot be shown in this half an hour, some of them which I felt interesting to me, and I hope you also will find it exciting, and what is happening not only in India but also in the world as a whole. So one is what is shown here in the phase diagram of water. You are all familiar with this. Water exists as liquid, solid and vapor, and there is a tri-critical point, and that is where water exists in the three phases. So this is all known to us, and what is shown here is also a familiar figure for high energy physics people. What is plotted is density versus temperature. This is the hadron phase where you have the neutrons, protons, and then going to the quark-gluon plasma. That is the phase where it translates to quarks and gluons. This is a topic of intense activity over many decades now, and many interesting discoveries have been made, and the phase transition going from hadron phase to the QGP has been firmly established, but still there are many interesting points. And once upon a time they said this QGP takes place only when you have two heavy nuclei collide, because that is where they said the conditions are very right for formation of QGP. But then over the years, what I find recently, even LHC, they have found QGP even in oxygen-oxygen collision. So if you have the right conditions of energy and density, then you can have the phase transitions taking place. And this is possible to achieve because you have different machines, either the accelerators, Brookhaven, RIC, or the LHC at CERN. You can vary the energy and the nuclei colliding, so you can have different conditions of temperature or energy and densities, and then it is possible to investigate this kind of phase transitions. And one of the crucial questions in this phase transition is where is the critical point or the region where this transition is taking place. And of course, as you can see, this is a little broad, the transition region. here it is becoming a little narrower, and there is a critical point, which is what is sort of predicted from theoretical considerations. So this has been a goal. People have been hunting for this critical point, and what is the evidence for this? What is said? How do you find that something is there? So there should be some variation between this side and that side. So what is that variation? There will be some fluctuation in some of the physical observables, and that is what people have been looking for. And so one of the, just shown some results by the RIC collaboration, and at the critical point, fluctuation in the ratio of deuteron to triton across the two faces expected. There seems to be a correlation between particles and the distant neighbors, and that leads to fluctuation in the observables, physical observables, and this is one of the predictions. And the ratio, as you can see here, in this region of energy, 20 GeV, collision and center of mass energy, you have some variation with respect to this trend. So this, it is believed to be an indication that at this energy, there is a critical point between the two phases. Again, one more recent experiment. This is regarding the proton-antiproton number in terms of the moment distribution. Again, they find some kind of anomaly in this region. Of course, a lot of, this is the general trend, and this is the anomalous region, again around 20 GeV or so. So people believe that perhaps we have some evidence for the critical point occurring around this energy. Another field which is interesting, you all know that hyperons, like neutron, protons, the hyperons have in addition to up-down quarks, you also have the strange quark. A lot of work has been done in hypernuclear physics, but not much has been seen on anti-hyperons, the counterpart of hyperon. And there has been again the STAR experiment at RIC. They found in more than 10 years ago the anti-hyper triton, then anti-hyper hydrogen, then recently they say they have evidence for anti-hyper helium, which means 2 protons, antiprotons, 1 antineutron, and 1 anti-hyperon. This has come in this PRL. I believe this has implication for core of neutron star. By the way, I am not an expert in this kind of fields, but whatever I have read, I am just sharing with you. You know that in stellar evolution, nucleosynthesis started with the Big Bang. You have the Big Bang nucleosynthesis. After some millions of years, the synthesis continued in the stars, because stars have to be formed, and then the nucleosynthesis continues in the stars. And in the Big Bang synthesis, you have neutrons and protons, and light elements got created. So that's what happened in the NP fusion. At the end of this phase, the Big Bang nucleosynthesis, you have to remember the neutrons got exhausted. So when you have this nucleosynthesis continuing in the stars, what is the source of neutrons? The neutrons were there in the beginning, but they are not there anymore. So they have to be produced by some reactions. And you know the neutrons are very important for element formation beyond iron and nickel. Up to iron nickel, you have the nuclear fusion, which is important to produce these elements all the way from hydrogen, helium, carbon, oxygen, neon, etc. But beyond iron, you have to have neutron capture reactions. It could be slow neutron capture or rapid neutron capture. This is what is the main process by which the heavy elements are formed. Now, what is the source of neutrons for this to happen? There are 2 reactions which have been identified. One is carbon-13 alpha N reaction. The second one, that is a positive Q value reaction. The second one is neon-22 alpha N reaction, which is negative Q value, but not very much. So just now I will discuss what is the status of neon-22 alpha N reaction. I believe some of this we can even try to do right in the country. So these are the two reactions which produce the neutrons required for this S process, important for formation of heavy elements. Let me go through the status of So first of all, how do you get neon-22? So you have CNO cycle. You have, there are many possibilities. P gamma, positron decay, alpha capture, all capture reactions. So 18 oxygen which is formed here, alpha capture can give you neon-22. So we are talking about neon-22 which is formed in CNO cycle or near to that stage of stellar evolution, and that becomes the target, and then alpha capture and alpha N reaction. These are the two reactions which are important. Alpha N leads to neutron production, alpha gamma leads to destruction of neon-22. So we have to take into account the destruction of neon-22 by alpha gamma reaction and also formation of neutrons from alpha N reaction on neon-22. So both these reactions are important. So this is the strength of, there are a number of resonances in this reaction. This is bombarding energy here, very low energy, around 1 MeV and less. And this is the cross section in microbond. You can see I think 10 power minus 10. So such a low cross sections you have to measure, and this is related to that this resonance. The strength is plotted here. How the number, the particular strength of this resonance at 700 keV has been measured over the years. You can see from 1991, 93, 2024. So the number finally is around this. And this is one of the latest work, I think. Yeah. No, this one. This is the latest. So you can see that the error bar, so this is also very important in nuclear physics. Even though you may not make a new measurement, but you will be making a more precise measurement with less of uncertainty. That is also very important to get new physics out of it. So this is a calculation by our own colleagues from Saha Institute. They have published it here. And this is an R matrix analysis of the data. And there is a resonance around 500 keV which is not still established. So this is something which is an open problem. The resonance around 500 keV, it should be measured, and one should establish the existence of this, and also beyond, if any is there. There are theory gives you some more predictions. So the cross section you have to measure from nanobond to picobond cross section. So it is a challenge one has to undertake. So this is some experiment which is important for neutron production, which is again important for S process in stellar evolution. One of the recent things which I came across is a new accelerator. You know that Gran Sasso in Italy has been the leading lab for underground nuclear astrophysics. More than 20 years have passed, and they have been having some low energy, high current accelerator located in the underground, which is shielded from cosmic ray muons and things like that. So this lab, they have recently established a 3.5 MeV singletron accelerator underground. This is what I understand. And it can give you, this is the kind of shield, the earth shield they have. Helium-4, 500 microampere. Proton, 1000 microampere. Carbon-12, 100 microampere. And this kind of facility is now operational at Grand Sasso. And this will, they will be tackling some of this, which they could not do with their 400 kV machine, which they had earlier. So this is an interesting development. I understand Dr. Santra and colleagues are planning to build underground facility for astrophysics. So I think that, in fact, we should also think of sometimes joining this kind of collaboration and participate in some of, just like we have been participating in LHC and other places, we should also go and take part in this nuclear astrophysics work done underground. As you know, the nuclear fusion, heavy ion induced nuclear fusion has been in existence for more than 5 decades. All of us have enjoyed doing these nuclear fusion measurements using our facilities. This nuclear fusion got a boost in the 1970s, late 70s, thanks to the work of Stockstad and company in United States. They measured the fusion cross-section for a variety of samarium isotopes, 144 to 154 with oxygen as projectile, and demonstrated for the first time the dramatic increase of fusion cross-section for 154 samarium when compared to 144 samarium. This was the beginning, I would say, of excitement in nuclear fusion, and it has continued all these years. And we have shown evidence for entrance channel, bombarding energy, nuclear structure of projectile target, deformation, whatnot, and transfer of neutrons. We have evidence for many of these. The rich interaction between nuclear structure and dynamics has been very clearly brought out in nuclear fusion studies. Particularly the subbarrier nuclear fusion, these effects are very dramatic. So I recently, Jiang and company from Oregon, they again, as you know, that empirical description of data, even though it is just parameter playing work, but many times I have found it systematizes a large number of data, and sometimes it also brings out underlying physics, which gives you food for future investigation. So Jiang and company, as you know, that many years ago, we all used to get the barrier distribution starting from nuclear fusion excitation function, and that brought out some information regarding the coupling. Similarly, he has just tried to scale the cross-section and energy in some way like this, and then plotted the data to see what kind of feature it gives. And there is also another thing which you are all familiar, dE sigma fusion divided derivative of cross-section energy product divided by this. It is related to the curvature of the excitation function. So let us see, by doing this, what do you get? It is only rescaling the energy and cross-section the way it is defined here. This is given in this paper. So the first left-hand side, this is our regular excitation function. Fusion was the energy. You can see that 144 is here and 154 is here. This is log scale. You remember how much enhancement is C. It is a tremendous enhancement of fusion cross-section at these energies. And the same thing, if you plot in that rescaling of energy and cross-section, then you find, interestingly, it becomes a universal curve. All systems, they lie in some kind of universal curve when you do this rescaling. And the third one, energy is scaled, but cross-section is not, cross-section is multiplied by energy. This is another way of plotting the same data. Same data plotted in different ways. Then you see that 144 is here and 154 is just shifted with respect to this. And the ratio of the two is related to the enhancement. How much is 154 samarium cross-section is enhanced with respect to 144 samarium. That comes out very beautifully when you do it in this way. And the third one is that derivative, sigma E here and d sigma E derivative here. Then you see you have this slopes parallel to each other. This is just to demonstrate the same data can be depicted in different ways by scaling the x-axis and the y-axis, and then to see whether some interesting physics comes out of it. So this is done by Stefanini group. This has come in this scientific reports. What I found interesting, you see here, these are the systems where inelastic coupling is the dominant factor. And you see they all lie in one curve. These are the systems, 96 zirconium plus calcium 40, nickel 58 and 64, where neutrons transfer is more dominant, that coupling. And they see that these two lie here. So by plotting the cross-section data this way, they are able to separate the systems which are influenced by inelastic coupling from the systems which are influenced by the neutron transfer coupling. So I find it is very interesting to depict this way. Another area which has attracted a lot of interest in the recent years, I would say last 10-15 years, is nuclear fission and mass distribution and fission in particular. You know that nuclear fission is more than 80 years old and it continues to be challenging and puzzling despite all the advancements we have made over the decades. What is the new interest? You know, the mass distribution has been measured right from the days of Bohr, and you know that at low energy induced fission, neutron induced fission, the mass distribution, what is plotted is the fragment mass and the yield or cross section. At low energy, you see that you have the asymmetric division of the fragments. One light fragment here and one heavy fragment. This is thermal neutron induced fission. But when you go to a 0.5 MeV induced MeV neutron fission of 239 plutonium. When you increase the energy of neutron, then you can see this valley getting filled up and it is becoming more and more symmetric. This is a well-known thing which people who have been doing fission will appreciate. And so what is interesting, when you have actinides like thorium, uranium, plutonium, neptunium, and all the heavier ones, when they undergo nuclear fission, the heavy fragment and the light fragments are get detected separately in the experiment. The heavy fragment, the atomic number or the charge proton number, very interestingly, they all lie in this line. Thorium to fermium. The heavy fragment, the charge number of the heavy fragment is around 54, 55, 56, around that. Whereas the light fragment charge number will increase with increase of the mass number of the actinide. This was an observation known to us quite some time. What is new which happened in the recent years? So you can see that since 2010, sparked in mass fission, because the pre-actinides, you know, fission of nuclei with mass number 200 and less, that has happened in the last 10 years or so. That has again sort of renewed interest in mass distribution. And anyway, this is a figure you may not, but you can see that some are symmetric distribution, some are asymmetric mass distribution. All kinds of features are exhibited by these nuclei from Rutherfordium to osmium. This I took it from International Conference on Nuclear Physics 2025 by invited talk. And a lot of work has been done using 1 AGV uranium on beryllium target, fission of 100 nuclei. They could do in one go 100 nuclei and fission of 100 nuclei. I think they have just made everybody, sort of with no work, because they have been able to do 100 nuclei in one experiment. This again, some recent work from the BRC group. So what they have found, you remember when the fission of actinides, the heavy fragment had some systematics with charge number converging around 54 to 56. When you go to lighter nuclei, pre-actinides, mass number less than 200, 220 of that order, the light fragments have almost the same charge number, whereas the heavy fragment has charge number increasing with increase of the fissioning nucleus. This is a new feature which has come out of the work done in the last 10 years. So what has been seen, this is the light fragment. The charge number is around 36. For actinides, the volt, the charge number of heavy fragment is 52, 50, 54, something like that. For pre-actinides, that is mass number less than thorium, then the light fragment is, charge number is constant. Here it is heavy fragment, charge number is constant. Of course, this is an experimental fact and some explanation is available. I think this is a work where I think Dr. Ceremonial and others have done some work. They have tried to give some explanation from potential energy surface how the deformation, octopole collectivity and shell closure for this deformation can explain this kind of feature. Or they made a prediction, I think this came much earlier. Anyway, so octopole collectivity of the fragment is one of the reasons why these things are clustering around 36 and 54 or 56. Of course, it is not clear, at least to me, why a fissioning nucleus, which of mass number 230, 240, decides to end up with Z equal to 54 or Z equal to 36. Of course, that is a dynamical evolution of the fissioning nucleus, where you have the collectivity as well as shell single particle effects coming into play. As you know that both these aspects, both the collectivity and single particle aspects, are a recurring theme in nuclear physics. All the time they are there, and you cannot say one is more important than the other. So this is something interesting. The people who are doing nuclear spectroscopy or nuclear structure without worrying about what is happening in the area of nuclear fission, they also have said large octopole collectivity is seen in this region. And it is an interesting coincidence. What was seen in nuclear fission systematics is already part of nuclear spectroscopy, where they have seen that collectivity is very important, octopole collectivity for this N and Z number. And again, so I find it's a very rich connection between the nuclear fission or reaction on the one hand and nuclear structure or spectroscopy on the other hand. Both are talking about the same thing, but but the only thing remaining is how the fissioning nucleus decides to take this, Z equal to 54 and 36. It is known from dynamical calculation, but it is interesting to know more about it. So identification of large octopole collectivity, I think Dr. Palit has a talk on this. This is something I found, again, there is some renewed interest in this topic. And octopole collective generally in neutron deficient actinides and neutron rich lanthanides. This is a permanent octopole deformation. This is well known. Many years ago this was pointed out. You can also have a dynamic octopole deformation. 220 has this. This is again, these are all the, octopole collectivity, and it's also related to shell closure for deformed nucleus. There is again a connection between the two. So, just like you have 2, 8, 28, 50, 82, 126 as magic numbers, when you take into account deformation, the magic number is no more 50, but it is 54 or 56. Similarly, 28 may be becoming 36 or something like that. Again, I think many of you may be understanding or appreciating, normally when you have even nucleus, both even, Z and N, the first excited state is always the 2+. That is what we generally see. But there are exceptions to this rule. One is the famous example of lead-208, which has 82 proton number and 126 neutron number. And the first excited state of lead, which we all know, is not 2+ but 3-. That is an octopole state. Again, this is dynamic deformation coming into play. And I think this is something I found interesting, which sorry. Why it is? Sorry, I must have. Oh, sorry. Anyway, so recently the gadolinium isotopes have been studied, and the first excited state is 3-, similar to lead. And this is the sort of, this is the PRL 2025. The experimental results are consistent with, again, theory is doing a good job. This, whatever systematic recently for gadolinium isotopes. The other topic which is again very lively is the study of dripline nuclei, proton dripline and neutron dripline. Today I am not talking about super heavy element because not much is happening, even though we have been expecting all the time the discovery of Z equal to 120. But so far it is still a puzzle, not happening so far. But dripline nuclei, they also have, that proton decay and neutron decay will take place from this proton dripline and neutron dripline. And I came across a paper where they have observed 5 proton decay from nitrogen 9. This I found very interesting. So this is, I have collected all the proton emitters. It could be 1 proton decay, 2 proton decay, 3 proton, 4 proton. Of course, this is stable. And the 5 proton emission, this is the recent one, which came in this PRL in 2023. So this is 5 proton emission, and you can see 1 proton is a green color, 2 is blue, 2 proton is blue, and 3 is purple, and then red is 4. I think Dr. Aradhana Srivastava was also involved in 2 proton decay, some experiments, and of course some heavier nuclei. So this is something interesting, not 1 proton, but even many proton emission can take place. What is the situation for neutrons? Neutrons, unfortunately, there are not many beyond 1 neutron, 2 neutron, 3 neutron itself is very difficult, and 4 neutron, 5 neutron, of course, have not been observed. It is also difficult because how to form this neutron-rich nuclei, which close to the drip line. The formation of these nuclei also is a challenge, and also they have to only overcome the centrifugal barrier, whereas the proton thing, which is little more easy to populate, they have to overcome the Coulomb barrier. And in the case of neutron emission, you can have both ground state as well as beta delayed neutron emission is also possible. Some are branching for 1 neutron and 2 neutron. It is not just 1 neutron, it can be having some percentage 1 neutron decay and some percentage 2 neutron decay. And again 1 neutron is here, and then 2 neutron and 3 neutron. So more difficult to produce and very short half-lives, because that is also very important. If the half-life is very short, you cannot measure many of these things. So this is something I found interesting. Another thing, of course, is the, one of the famous example is the calcium isotopes. Like lead, it is also an interesting thing. You have many isotopes for calcium, and usually the identification of shell closure is made through plotting the 2 neutron separation energy as a function of mass number, and whenever there is a dip, that is an indication of shell closure. So they found that around n equal to calcium 60 is not a magic nucleus. Maybe it was believed because 20 and 40 is also supposed to be a shell closure. So people were expecting calcium 60 will be magic, but it doesn't seem to be, based on whatever has been measured recently. 52, 54 have been measured. No magicity for calcium 60, but next magicity is indicated for 70 calcium. Of course, we have a long way to go. So this is an open problem to confirm that calcium 70 is indeed magic. So N40 shell gap is not preserved because we are not seeing calcium 60 to be the magic. This is again this reference, those of you interested can see. As I mentioned, that we have excellent facilities in the country, the INGA. This is one of the reasons for the successful collaboration in the nuclear spectroscopy. Almost all the institutions joined hands and built this world-class facility, which used to go from Delhi to Bombay to Calcutta, but now I understand it is probably stationary in one place, and each group building large number of detectors to make independent arrays, which is probably the requirement of the group of people doing nuclear spectroscopy. The charge particle array, neutron array, spectrometers, the charge particle array, they are all available in Delhi, Bombay and Calcutta. And so they are all world-class facilities. So the people doing nuclear physics research, the young research scholars, they can be very proud that they have world-class facilities right in India. We also have just operational in the last 1 year or so. Then at Kolkata VECC, they have the room temperature cyclotron and the superconducting cyclotron. I'm happy that the superconducting cyclotron is fully operational, delivering beams, and people are doing experiments. At Delhi, they have the 15 million volt pelletron coupled to LINAC. This one is an advanced stage, the high current injector based on ECR, RFQ, low beta, LINAC and all that. At Kolkata, they have a 3 million volt tandem at Saha Institute, Bhubaneswar, a neutron generator, BHU, Pune, Dhruva reactor for thermal neutron. We also have good facility at Dhruva reactor at BRC. I must have missed 1 or 2 facilities in the country. So we have a lot of facilities for doing top-class nuclear physics research. I'm happy that this mega science vision nuclear physics 2025 will be discussed in the symposium. This is what I gather. Formation of National Detector Development and Training Center. This is one of the recommendations. Underground facility, nuclear theory center. Many of you may remember, I think Professor Jain and Professor D.K. Srivastav, they also started this activity maybe 10-15 years ago. So same thing is again coming back again to do nuclear theory, is starting a center. Training and retaining human resources. This one also we discussed much earlier also. And formation of Indian Nuclear Physics Association. Recently I came to know from Professor B.P. Singh. I think Professor Jain is the chairman of this activity. I'm sure he will take it forward. And similar thing happened even in the Asia. There was an Asian Nuclear Physics association. Similarly, you have, but then this association, they have to come with recommendations, and finally, how to implement some of these recommendations. That is where we require the support of the funding agencies, both the DST and DAE. These are the two major facilities I'm sure will be discussed. One is the ANURIB, the RIB facility being built at VECC, and this one will have finally, when built, 100 MeV per nucleon RIB, electron linac, ring cyclotron as drivers to produce this RIB species, either directly or gamma-induced reactions or neutron-induced reactions, and linac and ring cyclotron as booster. I will not go into the detail. So it will have accelerators. So a lot of development of accelerators, indigenous development is required, and all kinds of instrumentation will be required, and all of them we built with indigenous, and with, of course, wherever possible, cooperation with experts from abroad. The other one coming up at Vizag BRC campus, Dr. Aradhana and colleagues have been spearheading these efforts. This one, PF and PXN reaction. This is the driver, photofission, and then a linac booster. This will be, they are hoping to get 10 MeV per nucleon RIB. So this will all have some time scales, and as you know that it is easy to draw this figure, but then each one is so challenging. We'll have to get together and see how we can realize our dream of having a state-of-the-art radioactive ion beam facility in the country as soon as possible. So the outlook, of course, I have only given a glimpse of what I found interesting in the last 1 or 2 years. So you can see that nuclear physics continues to be exciting, and the old anomalies get resolved and new puzzles crop up. So that is a food for us to solve. And nuclear fusion and fission, as it was mentioned, over the years, more than 50% of the papers are basically nuclear structure and nuclear reactions. That is where the major community of nuclear physics are there in the country. That is also expected because we have facilities mostly for these kind of studies, structure and reaction. So with the facilities we have in the country, that is why we have more of this nuclear reaction and spectroscopy specialization. Now the time has come, we have been doing many targets, projectiles, and we have a lot of expertise all around the country. This group of people should get together, I would think, to see that, make a few measurements. I think Dr. Professor C.V.K. Baba used to say that we should have one group experiment, Instead of doing each one doing some experiment, why not do once or twice some group experiments, expertise coming from different parts of the country, and do 2 or 3 experiments and try to resolve some problem which is outstanding. Otherwise, each person will do with existing computer program, analyze his data and come with some parameters. I think that we have been doing very well, but I think a time has come to finally freeze and converge on sort of parameters or whatever we want to say, that it will be sort of globally accepted. The only note on caution which I have on this big facility building, because I have also been part of this facility building when I was in service, and I know the difficulties we had and how we have missed also some of the deadlines. As you all know that 2 MeV per nucleon RIB was to be available 10 years ago, but despite the best efforts from our colleagues, they have been able to reach up to 1 MeV per nucleon or something like that. I may be not completely right about the latest situation, because there are a lot of challenges and complexities in developing indigenously anything. So that is what we have to, we can do excellent experiments because we have facilities, but when you want to build the facilities, it is another ball game, and we have to not underestimate the challenges. I know how much of difficulties Professor Pillai and Kuru, they had building indigenously the superconducting LINAC. They succeeded, but I know the challenges they had to face en route, or our synchrotron at Indore. Again, it was great challenge with power cut and breaking down of things, but they finally achieved, and it is a world-class facility today running with so many users. So building facilities, that is where I think we require help of academic institutions like NIT Jalandhar and also industry, which we have been talking about it, but we have not still exploited. You know, everything doing it by only one institute like BRC or VEC or TIFR or Saha Institute. I think it has to go beyond that, and we have to build as a national effort. I think everybody should become partner. It should not left to the BRC or VEC to develop it, and do its own course. Then it will take its own time. If everybody joins hands and develop some systems, then maybe we will achieve it at a faster time scale. This is the only sort of advice, because I am old to give advice. So this is something which I hope we will take it in the right spirit. And I have been talking about it that we should have a national effort, national steering committee for some of these, because there is a lot of investment, cost-wise also, and time-wise, and manpower. So unless we do it as a national program, like INO, we started as a national program. So it should always be a national program. Even the INGA succeeded because it was a national effort. So again, request the people who are going to build these challenging facilities to take it in that spirit. And again, this will happen 10 to 15 years with our great efforts. So do we just wait for this, for RIB to happen, or can think of some RIBs, light RIBs? We know that 20 years ago, Beryllium-7 beam was developed at IUAC. I think Dr. Das and others were instrumental in developing this kind of facility. Why we have not gone for this kind of thing after that? We have stopped. Even though I used to tell Professor Mehta, because there is pressure of the stable beams, so they are not having time to develop this kind of RIBs at even place like IUAC, even though they can do it. So why not think of secondary reactions? There are many reactions I have discussed with some of the colleagues, either at Calcutta or Bombay or Delhi. Use that, and maybe, helium-6, beryllium-10. I understand Dr. Aradhana, Mumbai, they are planning to have carbon-14 as a beam. So we can think of some innovative ways of developing some low, light RIBs, even low intensity is all right. Let us have the culture of doing radioactive ion beam based experiments in the country while we develop our major facilities. So this is the only sort of advice I would like to give to the community. And I think end my talk here. Thank you for listening. Maybe I have taken a little more than what I should have.
Thank you, sir. Thank you very much, sir, for the insightful keynote.
Yeah.
So thank you very much, sir, for the insightful keynote covering recent development across many areas of nuclear physics. So unfortunately, following the Indigo and train, we are a little bit late, half an hour late in our session. So I request all the delegates to go out first for the conference photo, just outside the hall near the stairs, and then join us for the high tea. And I request everyone to come back at 12 o'clock so that we can proceed. Thank you.